Now, we will learn about the Newton's laws of motion. Newton has given 3 laws to describe the motion of bodies. These laws are known as Newton's laws of motion. The relation between a force and the acceleration it causes was first understood by Isaac Newton and is the subject of this chapter. The study of that relation, as Newton presented it, is called Newtonian mechanics. We shall focus on its 3 primary laws of motion. Newtonian mechanics does not apply to all situations. If the speeds of the interacting bodies are very large, an appreciable fraction of the speed of light, we must replace Newtonian mechanics with Einstein's special theory of relativity.
So from this slide onward, we will learn a very important topic of physics called Newton's law of motion. So what is Newton's law of motion? You have learned about the force, okay, and then the acceleration. The relationship between force and acceleration was first understood by Sir Isaac Newton. So in Newton's law of motion, what you understand? You understand the relationship between the force and acceleration. So this relationship between force and acceleration was first described by this man called Isaac Newton. This laws is one of the very fundamental law of physics. In fact, in almost all aspect of physics, you will see the application of Newton's law of motion. There are 3 primary laws of motion. We will learn one by one of all these 3 Newton's law of motion in subsequent slides. Just one caution or one thing that you have to understand. Newton's law is not always applicable in all the situations. Okay, so if the velocity of the object, if the velocity of the object is like velocity of a speed or comparable to velocity of a speed, then these laws fails there, and then that is replaced by another great scientist, Einstein, a special theory of relativity. So you will learn in the subsequent chapters, but here just for your understanding and appreciate the situation, the speed of light, which is represented by c, is something like 3 into 10 to the power 8 meter per second. So if any object which runs with this speed, the Newtonian's law that we are going to learn in the subsequent chapter will not be applicable. But for all the practical purpose in class 9th, this law will be applicable because we will be learning about the object of not that much speed, very slow speed like 3 meter per second, 5 meter per second. So you can compare 3 meter, 5 meter to 3 into 10 to the power 8 meter per second. So this slide is saying that Newtonian's law, there are 3 Newtonian's law. This Newton law is basically relationship between force and acceleration, and this is not applicable in all the situations.
Motion. Some of the bodies or objects around us are at rest, that is, they are stationary, whereas others are in motion. Newton's first law describes the behavior of such bodies which are in a state of rest or of uniform motion in a straight line. According to Newton's first law of motion, a body at rest will remain at rest, and a body in motion will continue in motion in a straight line with a uniform speed, unless it is compelled by an external force to change its state of rest or of uniform motion.
This is Newton's first law of motion. So you have to remember this statement of Newton's first law of motion. I will explain you in this slide and subsequent slide, but try to remember. A body at rest will remain at rest, and a body in motion will continue in motion in a straight line with a uniform speed unless it is compelled by an external force to change its state of rest or of motion. What does it mean? It means if a body, okay, is at rest, means velocity is zero, it will continue to be in rest. So it will continue to have velocity zero unless and until this there is a force, okay, in either direction. If there is a force, okay, and when I say force, force the not balanced force, unbalanced force. If there is a balanced force, again it will, the resultant force will be zero, and then the body will continue to be in the rest. So when an unbalanced force, so maybe F1 is much bigger than F2, then the state of this object will change. So the velocity of this object will change only when there is a force applied. Otherwise, this will continue to be at the rest. Similarly, if a body is moving with velocity v in a straight line, this object B will continue moving in a straight line with same velocity v unless it is again acted by an external force. So if an external force apply on the body now, this was initial velocity v and then there is a force apply, then its speed will change. Okay, so here there are three terms. The rest means a body is not moving, so its velocity or speed is zero. And uniform motion means a body is moving with a constant speed or velocity. So Newton's first law of motion describes a body which is at rest or moving with a uniform velocity in a straight line. So what Newton's first law of motion is saying, a body at rest will remain at rest, and a body in motion will continue in a motion in a straight line with uniform speed unless and until it is compelled. Compelled means unless and until it's applied by an external force to change its state of rest or of uniform motion. That means what? I just have explained you. If a body A is at rest, it will continue to remain at rest unless it is applied by external force. Similarly, if a body is moving with velocity v, it will continue moving with velocity v unless it is applied by external force.
Let us understand what first law of motion is saying. With no outside force, the object will never move if it is stationary. Also, with no outside force, a moving body will never stop.
So again here we have this example of Newton's first law of motion. What does it mean? It means if this object, we have just seen in the previous slide, if this object A is at rest, okay, it will continue to remain at rest. So velocity will never change unless there is a force applied. If there is no force, there will be no change. If there is a force, there will be a change. Similarly, if a body B is moving with velocity v, okay, maybe velocity v can be anything like 3 meter, 5 meter, 20 meter, 200 meter, 2000 meters, any meters. It will remain in the same velocity unless and until it's applied by an external force. So this is this example. Now, in the tabular form or in the graphical forms, Newton's first law of motion can be explained like this. So if force is a balanced force, means if resultant force is zero or if there is no force applied, then acceleration is zero, means object at rest will remain at rest and object in motion, okay, stay in motion in the same speed and direction. Now, how we denote the object in motion is velocity not equal to 0. You remember this sign, not equal to 0. That means there is a velocity which is not equal to 0. That means object is in motion. So that object will remain in that motion if force applied is 0.
The tendency of a body to remain at rest, stationary, or, if moving, to continue moving in a straight line is called inertia. Newton's first law recognizes that every body has some inertia. Inertia is that of a body, due to which it resists a change in its state of rest, or of uniform motion.
Okay, so here we will learn a new terms called inertia. Okay, what is this? Inertia. Now Newton's first law of motion is saying this property about all objects. So all objects has this property called inertia. So it's very important. Newton's first law of motion introduces a new terms for us. What is that? Inertia. We'll try to understand what is the inertia. Okay. We have seen what is Newton's first law of motion. A body will try to remain in the position of a state or in a uniform motion unless and until it is applied by an external force. So that property of the object through which it remain or it resist any change is called inertia. So try to remember this. Inertia is that of a body due to which it resists a change in the state of rest or of uniform motion, and inertia of a body depends on your mass. Okay, so if a body has a smaller mass, it has lesser inertia. If has a body of larger mass, it has obviously larger inertia. So there are two things. The terms inertia. Inertia is a property of a body which resists a change in a state of rest or of uniform motion. And inertia of a smaller body is small and a larger body is large. So for example, 1 kg body, okay, will have a lesser inertia compared to 20 kg body. Okay, so inertia, you understood the terms inertia. Inertia is property of a body which resists any change in its state of rest or uniform motion. And this terms came out of Newton's first law of motion.
Let us understand inertia by examples. A toy car has a small mass, so it has small inertia, and hence can be moved easily by pushing. A real car has a large mass, so it has a large inertia, hence quite difficult to move by pushing. From the above discussion, we conclude that to overcome the inertia and make a body move from rest, we must apply an external force.
So here is the live example of inertia. See, this is a toy car. Okay, toy car has a lesser mass than your actual car. Okay, so now toy car you can just gently push, okay, and it will move. In the large mass of your actual car, on which you ride or drive, you need a bigger force. Okay, why? Because this body has larger inertia than this one. Okay, so this has a smaller mass and this has a larger mass. So a smaller mass will have lesser inertia, and larger mass has a larger inertia. So what we conclude from here, a smaller body has a smaller inertia, a bigger body of a larger mass will have a large inertia, and to overcome this inertia you need to apply a force. Okay, you need to apply a force. So in Newtonian mechanics, you see force plays very important role. So even in the first law of motion, you see there is a inertia, and to overcome the inertia, you need to apply a force.
We can illustrate the Newton's first law of motion, or the property of inertia, of a body with a simple experiment described below. We take a glass and place a thick square card on its mouth. A coin is then placed above this card in the middle. Let us flick the card hard with our fingers. On flicking, the card moves away, but the coin drops into the glass. We will now explain how it happens. Initially, both the card and the coin are in the state of rest. Now, when we hit the card with our fingers, a force acts on the card and changes its state of rest to that of motion. Due to this, the card moves away from the mouth of the glass. The force of our flick, however, does not act on the coin, so the coin continues to be in its state of rest due to its inertia. And when the card, on which the coin had been placed, moves away, the coin falls into the glass because it prefers to maintain its state of rest due to inertia.
Okay, so you understood. This is a simple example to illustrate Newton's first law of motion. What you do, you take a glass, you take a card. Okay, on top of the card you place a coin, 1 rupees, 2 rupees, whatever coin you want to put. Now here you see both glass and card is at obviously rest, means it's not moving. Now what you do with your hand and your finger, you apply a force on this card. Okay, you apply a force. So when you hit the card, what basically you are doing, you are applying a force. So when you apply a force, what will happen? The card will move. Okay, the card will move. Why card moved? Because you applied a force. When a card moves, the card will go away from here. Okay, but think about the coin. You didn't hit the coin. So what will coin do? Coin will remain in the state of rest, means remain rest. And then when there is no card, it will fall down. Okay, so what you understood, there are two aspects that you understood. If no force, okay, no motion. This is for what? This is for coin. Okay, and what is the second thing? This was first thing. What was second thing? If force not equal to 0, then you get a velocity not equal to 0. Understood? So here the card, okay, you applied a force and it moved. And coin, you didn't apply the force, it fall down. So this is the Newton experiment to show Newton's first law of motion.